In this session, we will discuss about different perspectives of artificial intelligence with use cases in real world scenarios. And for different implementations, for different demonstrations, we will cover some very high performance frameworks and libraries under pre-trained implementation models. Generally, when this particular topic is covered, artificial intelligence, in which there are multiple segments are involved, like machine learning, deep learning, ensemble learning, federated learning. So it is a very common misconception that we have to work on some particular very complex programming environment. But nowadays, whether we are working in computer vision, natural language processing, biometric applications, or any other scenario, there are lots of platforms available in which, in very less lines of code, we can work on AI based models. As all of you are academicians, you might be working on different research projects, you might be supervising research scholars. So artificial intelligence can be integrated in multiple segments, not only in a particular scenario. So first of all, we will see where we can implement, where we can use artificial intelligence for high performance applications. Swarm drones for military applications. You might have seen nowadays so many defense organizations are using drones in which automatic capturing of images are there. So what will be the major benefit of this scenario? Obviously, minimum human loss or zero human loss. Rather than deploying army in physical mode, rather than deployment of human beings, nowadays artificial intelligence based weapons and robotic applications are available. Dynamic detection of objects and accurate marking of that specific target, accurate shot down of that particular target in whatever weather, in whatever climate we want to deploy an operation. You might have heard so many scenarios. So first of all, we are covering about different use cases, different implementations, and after that we will see those platforms which we can use for such type of applications. For example, we want to create a particular scenario, we want to deploy a drone, so how to integrate some programming platform. Okay, we will cover that part also, but first of all we will see where we can use computer vision, real time object detection. You might have seen at the time of curfew, lockdown, nowadays drones are implemented for law enforcement, real time number plate detection, dynamic OCR, optical character recognition. And in minimum lines of code, in 5 to 10 lines of code of artificial intelligence based models, we can deploy such applications. Speech recognition. So all of these are very prominent and key areas of applications. You might have seen nowadays many of us are using Alexa, Amazon Fire Stick. So by simply releasing a particular voice, we can give a command to a specific object, to a smart gadget, and it will automatically identify what we want to say, what we want to point out in that specific audio, in whatever scenario we are there, whether there is some noise or not. Artificial intelligence based pre-trained models are efficient enough to capture the integrated data or that particular command. So vehicular detection, number plate detection, and for such type of applications we generally think that we have to work on very complex architectures, very complex programming platforms like Python or Java. But currently, very easy to use rapid application developments are available. RAD frameworks are available in minimum lines of code with very base level hardware. We can deploy artificial intelligence based models. And all of these we should be aware. So, as in this particular STC, major focus is employability, skill development. So, whether you are from CSC background or electronics or from any other domain, these are very easy to use platforms and everywhere we can deploy it. Whether somebody is from agriculture or from humanities, without worrying about any complex programming in very less lines of code, in very minimum infrastructure, we can work. Whosoever knows how to work on computer, they can work on such type of implementations. Face emotion recognition. From somebody's face, we want to recognize their sentiments, emotions extractions. So, different use cases in education, in academics also, it can be implemented. For example, in a particular online session, we want to extract whether participants are contented or not, whether they are satisfied or not. Obviously, it will work only if webcam will be on. So from facial expression recognition, we can identify emotions or sentiments or contentment level of our students. So not only for criminal detection, not only for e-commerce, in academia also, artificial intelligence based models can be deployed. Okay, so these are the key phases when we work on some artificial intelligence based models. Okay, benchmark data sets, deep learning units, which programming frameworks we want to use, whether we want to work on pre-trained model or custom model. But here we will see how to use pre-trained models. Major focus pre-trained models. What is major benefit of pre-trained model? No need to work from scratch. For example, we are working on real-time object detection. Okay, so in this particular scenario, for example, any scenario you can take, real-time object detection, real-time speech recognition. So in that particular scenario, start a particular model from scratch, then we will have to train a complete data set. What is major benefit of using pre-trained model? No need to train a particular model from scratch. Each and everything is already available. So I'm showing you some links. Coco dataset. Okay, so Coco dataset is available. ImageNet is available because at the base of artificial intelligence, at the base level of machine learning or deep learning, major point is data set. For example, you are working on some robotic application, you want that that particular robot should be able to recognize each and every object in front of it. So definitely in that case, that robot should be having each and every image of this world, each and every object with different variants. For example, one particular creature. So that a particular creature feature and figure is different throughout the world. If we will if we take an example of like elephant, Indian elephant shape and orientation of Indian elephant is entirely different from African elephant. So how it is possible that um, in a particular drone or in a particular robotic application we can train each and every type of shape, each and every type of aircraft, each and every type of object, millions of objects available throughout the world. So how to train each and every object in artificial intelligence model? And one thing we should be clear that if we do not give accurate data, if we do not give accurate data set to artificial intelligence model, it will not give better prediction. Highest accuracy can be achieved in AI only with accurate and maximum data set. So that's why we use pre-trained models. In pre-trained models, no need to train any data set. All images, all data sets related to that segment is already available. If we take example of speech recognition in pre-trained models, for example, Alexa or Fire Stick, you might have seen when we release an audio, when we speak something, Alexa, open this, Alexa, perform this task. So it will recognize what we want to say. So what is that? How it is possible? Alexa is able to recognize voice of a child as well as a young person as well as a senior citizen. Same type of content is released by different human beings. Still, Alexa or Siri is able to recognize using pre-trained models. So we should be aware with these platforms how to use these pre-trained models for effective implementations. Are you getting whatever we are covering here? Is you getting all of these points? In chat only kindly confirm what is meaning of pre-trained model and its use cases. So no need to give complete data set from scratch. Simply we take a pre-built model. Now which are those pre-built models? In pre-trained models related to real-time object detection. For example, we are working on this type of application, this type of application. Different types of cars, different types of vehicles, their different orientations, their different shapes. So obviously we have to give complete data set of all cars of this particular world to that AI model. Only then it will be able to predict. But if we are using pre-trained model of AI, no need to give any shape or size or a particular orientation, it will detect automatically. So first of all, we will see which platforms, which libraries are available under pre-trained segment for computer vision. So as you can see, some libraries are mentioned here, exception, VGG16, VGG19, all of these are pre-trained frameworks trained on millions of images. You can see one ImageNet with 1.2 million images having 1000 classes. No need to give any data set. 1.2 million images are already trained. In same way, if we are using COCO dataset, so all images of this world, all types of aircrafts, all types of bikes, all types of two-wheelers, all types of creatures, these are already trained in AI-based pre-trained models. Simply import it and we can deploy for recognition. Okay, so you can see this is ImageNet. So it depends on that particular scenario where we want to use, whether we want to use for selected images or for all images of this world. So you can see that ImageNet, millions of images available. How many images? So these images already trained. No need to give any data set. And obviously it will be very effective for researchers also. If we are working on some research project for dynamic object detection, for deep learning, we can directly import these data sets. No need to take images separately and then training in a particular AI model. Is it visible to all of you? In chat, kindly confirm yes or no. Is it visible to all participants? So you can see, okay, and these are different variants of pre-trained models. Any of these we can take. AlexNet. So very soon we will see its demonstration also, how to work on real-time object detection. After that, we will see how to work on real-time speech recognition, natural language processing. In multiple segments, we can work. So we will start with real-time object detection. So any of these we can take, ShuffleNet, Inception. So if you are working on some particular drone application or some particular robot, simply import ResNet, MobileNet, and all of these provide very high accuracy, greater than 90%, greater than 95% accuracy we can achieve. Many times researchers work on medical data. In medical data also, we are having thousands of pre-trained models. For example, you are working on MRI data, you are having some X-ray images, we want to find out probability of arthritis. We are working on some bioinformatics based implementation for viral infections, for fungal infections. All of these models are available. Okay, so if we want to work on eyes based diseases, skin based diseases, VGGNet, tooth, brain, LXNet, DenseNet for lungs. Okay, so if we are working on some particular disease on kidney, disease on some particular ultrasound, So directly we can import inception model, and in 6 to 7 lines of code, in 10 lines of code of Python, we will be able to predict. And I'm showing you some resources also, which will be very, very beneficial to all of you, how to get detailed information about these data sets. Because when we work on some particular research based application, we need some authentic resources. So this is the resource BioRxiv. For example, you need to explore recent AI based models related to medical data. BioRxiv. This is preprint server for biology. Preprint server means those research papers which are yet to be published after 2 months, after 6 months, after 1 year. What will be benefit of this? We will come to know about latest work in these segments, in whatever domain you are working. Okay, for by any way, if your work is related to medical, in same way, medRxiv. So preprint server. So in any of these segments, if you want to implement artificial intelligence, you need to see which pre-trained models are available, which data sets we can put in our AI model, which are authentic sources of data sets. medRxiv. Okay, so in same way, XNet, Doctor AI. So all of these are pre-trained models. Okay, so for exploration, for detailed analysis, you can refer these repositories. If your AI based implementations are related to blockchain or some other domain like astronomy, quantum physics, quantum computing, you can explore ARXIV related to engineering and technology, science, engineering and technology. So for pure and applied sciences, engineering, technology, we can refer to ARXIV. If our AI based implementations are some way related to medical, pharmacy, and health sciences, then BioRxiv and medRxiv. Okay, so all of these domains available. You can see nuclear physics, nuclear theory, and here we can explore machine learning or whatever domain we want to work. So you can see that very latest papers. So 18th January 2023, yesterday. So very latest work. Otherwise, if we are taking some research work from IEEE ACM, in that case, they may not be novel, they may not be latest. Why? Because if some particular paper on AI or any other domain is published today in IEEE or in whatever journal, everybody knows that that paper might be submitted 2 years ago or 1 year ago, and before that, that particular researcher has started work on that. Okay, but here we can get those resources which are to be published, which are only accepted. Okay, so latest ideas about data sets and resources we can take from here. Okay, so you can explore it. Now we will see those platforms which are used in artificial intelligence for real-time object detection, real-time object analysis, dynamic biometric evaluation. So you can see very first platform that we will cover here is MediaPipe, product of Google, but currently it is deployed for researchers so that they can work on their own implementations. If somebody want to use live machine learning with minimum lines of code, MediaPipe can be integrated. Completely free and open source. So you can see, for example, you want to work on face detection. No need to train any data. Pose detection. And in whatever programming language you are comfortable, you can deploy it. If we want to create an Android app, it can be done iOS, C++, Python, JavaScript in Node.js. In which particular scenario we want to work? Face detection or iris detection, holistic analysis, hair segmentation, Objectron. So you can see each and everything is available. Okay, so you can see that. For example, we are working on gesture recognition, palm detection. Okay, palm detection. Everything is available here. Okay, and complete source code is provided here. Complete source code. No need to worry about the programming part. So its base is computer vision. You can see here CV2, computer vision, and source code is provided. If you want to create its web application, JavaScript code. In same way, if you want to work on AI based implementation for Android app, so you can see Android solution API is provided here. We can directly take this code and it can be deployed on our scenario. Okay, and before implementation, you can see that it's Google Colab notebook is provided. On Google Colab we can execute, we can see its demo also. Okay, on Google Colab. So this is a complete source code. So this code we can put if we are working on some particular hardware like Raspberry Pi or Arduino. In that we can burn this code. Holistic detection. You can see that fingertip detection, gesture recognition, everything we will be able to recognize from a particular human being. We want to detect their emotions, we want to note down their emotions. Okay, and you can see that in minimum lines of code we are able to work. Okay, so this code you can directly put in your system, in your hardware, and directly we will be able to work on real-time object detection or selfie segmentation. So I'm opening that so that in this particular laptop I can show you one demonstration on same scenario. Okay, So same code I have put in this system. Okay. So hand gesture analysis. As I am sitting in front of the camera, so my hand gestures will be visible here. Okay, so you can see that. So is it visible? So you can see that any type of data we can take. So both on both hands we can work. So by this way we will be able to detect human gestures or their behavioral analysis, and any type of data we can take. As there is one query about spatial data. For spatial data also there are different pre-trained models available. In medical data also we are having multiple pre-trained models. Okay, so for example, if you want to install it, so directly, so you can see that its complete documentation is given. Installation. If we want to work on satellite data, that is also available. Okay, on multiple operating systems you will be able to work. Okay, how to install it? Simply media pipe. Okay, pip install media pipe. And box tracking, object detection. If you want to view a web demo, for example, facial expression recognition. Okay, so you can see that OpenCV, import OpenCV. This is CV2, and with directly media pipe, we will be able to integrate. And if we are working on some research based task, this code can be customized. Okay, this code we can customize, and we will be able to create a fine-tuned model. Okay, so at bottom, so you can see that at bottom its web demo is provided. So if internet speed is fast, then before installation on our system we can view its demo, so that its preview can be seen. Okay, so how many number of faces we want to recognize? So complete web demo is provided, and we can integrate our webcam selfie mode on or off. Okay, different parameters we can set. And its source code for research based implementations, we need its source code so that we can customize it for fine tuning for better results. So you can see that its complete code is available here. Okay, so here segmentation, and we will be able to view that file. Okay, so you can explore it. At end of this session I will share this presentation to all of you so that you can work. Up to this point, is it clear to all of you? Kindly confirm. Up to this point, is it clear to all participants? Now we will see some other applications, some other implementation scenarios for artificial intelligence, including natural language processing in minimum lines of code, in minimum scripting, in pre-trained mode, by which way we can work. So you can see huggingface.co. If we want to use a particular AI based algorithm that is developed by Google, these models are deployed on Hugging Face. Thousands of AI models which are created and deployed by corporate giants. These are available on Hugging Face platform. If you want to use an algorithm by Grammarly for natural language processing, Microsoft, Facebook, so you can see that thousands of data sets available in Google. When we search some particular query, you might have seen we are provided some suggestions. So I'm opening that. Okay, Google. For example, I'm typing here who is the cricket space. Now you can see that I have not written anything beyond this particular keyword cricket, but it is giving me some suggestions what I want to search. I want to use this algorithm. I need this algorithm of Google using which these keywords, these upcoming words are suggested. Okay, in same way, what is the name of space? Okay, Indian space. Now you can see that only this part we are typing here, and we want to use this algorithm of Google using which it is predicting upcoming word. These algorithms are available in huggingface.co. Okay, so name of this algorithm is BERT. So we can search for the BERT algorithm. BERT base uncased. So you can see that this is the model. Complete code is provided in 2 to 3 lines of code. Okay, so you can see that, and we can check its preview also. For example, we want to see, okay, what will be in space in this particular mask. Is the mask we want to fill in this particular blank using Google algorithm. This, okay, you can change this also. So before integrating to your hardware or robot or in your system, we can check its preview. Okay, for example, I want to be mask. Okay, or EISA. Somebody will search on Google, then what will be the next word? So you can see that it will predict in this way. Accuracy level. What will be the accuracy level of these words? At top, we want to be a. Okay. Now you want to put mask here. So wanted wants these. algorithm of Google. If we want to deploy it in cloud on Amazon SageMaker, we will be able to deploy it. Okay, so we will see its demo in Colab also, Google Colab. So for implementation with scripting, with coding, we will see how to implement it. Okay, BERT algorithm. So I'm opening Google Colab and we will see different predictions depending upon Google algorithm. So all of these are easy to use platforms, and we should be aware that AI based models are quite easy to deploy for real world applications. You can create, you can work on your own drone application, your own Alexa based application in minimum funding. So simply pip install transformers. So all of these are available, all of these AI based models are available in form of transformers. Pip simply in Google Colab pip install transformers, and after that we will directly come to that BERT model. So these scripts are already given on Hugging Face platform. So you can see that it is downloading the weights. Okay, these weights are getting downloaded. So what about these weights? These weights are having complete data set. These weights of AI based models assist us giving accurate predictions. Okay, so those transformers we can directly integrate, and so you can see that in script, if you want to predict, okay, what will be the next word after this, who is the richest, I'm not writing anything beyond this. We want to see what will be the prediction. At bottom we will see its output. So you can see that after taking weights it will give us those predictions. After taking those AI based weights, it will generate the prediction part. So you can see that it is giving prediction that who is the richest man. We have not written anything beyond this particular thing. It is the name of cricket space. Now we want to see what will be the next word. Crickets. Okay, so in this way, what is the name of run? And in very less lines of code, if we remove these comments, then it will be around 8 to 10 lines of code. You might have heard about of GPT. So GPT tokenizers, BERT, all of these are pre-trained on existing data sets. Are you getting this point? Is it clear to all participants up to this point, whatever we have covered? Or you can use this mask. Okay, and at bottom you can see its code is provided. This code we can directly take. In same way, if we want to integrate mask with script, so you can see that which model we are taking, BERT base uncased, and using this model what it will predict. So I, he, and what about the accuracy score? So if you want to change it, he is a mask. Okay. Okay. Mask means we want to predict using Google algorithm. Good man, guy, this. So different predictions depending upon BERT algorithm. Otherwise, if we will generate a script for BERT algorithm from scratch, there will be thousands of lines of code. So rather than that, we can directly import pre-trained models. Okay, is this clear to all of you? Is it visible and clear to all participants up to this point? Up to this point, is it clear to all participants? And whatever we have covered so far in chat only can be confirmed. In same way, if you want to work on speech to text recognition, so in Hugging Face, simply we can explore different models, AI based models. Which model we want to explore? So you can see that in which segment of AI we want to work: text classification, token classification, question answering, or natural language processing. So in NLP, you can see automatic speech recognition, audio classification, okay, or automatic speech recognition. So you can see thousands of models, more than 6,000 models available. Very first model is from Facebook. So this algorithm, this framework is provided by Facebook and used by Facebook itself. For researchers, it is deployed on public domain so that other researchers can work. OpenAI, so many libraries of Facebook. If we want to work on multilingual data, we can work. So we can check, okay, what will be its output. Okay, so anything, any file we can take. So if we want to work from scratch in scripting part, we can take this code. If we want to work on cloud, Amazon SageMaker, okay, automatic speech recognition, browse for file. Any file we can upload, any wave file, or record from browser. Recording from browser, and we can check. So compute. So whatever audio is there, so you can see that I was speaking at that time recording from browser, so it has detected my voice. So whether voice quality is good or bad, it will able to identify. Okay, or real-time speech recognition. If you want to deploy it in a hardware, in a robot, simply we can take it. Okay, Another scenario we can take, another example, for example here, record from browser. So recording from browser can be done, and you will see same text typed here after stopping it. Stop, compute. So you can see that. So recording from browser. So this is the same thing which I have generated, and exactly it has identified that text from audio. So speech to text recognition using Facebook algorithm. How much it is easy. So hello. Okay, so you can see that only hello, and it is converted with very high accuracy. And you can see that. What about the backend system? How much time it has taken? 1.03 seconds. And if it is fine for our work, then it can be integrated on our system. Okay, its complete documentation we can refer, because when we implement something we have to give its reference. So using which transformer, using which approach it is able to identify. So in the same way, models. Okay, and audio classification or text to speech, anything we can take. So which algorithm we want to use, Facebook algorithm or ESPnet. Okay, hello to all. So you can see that model is loading. So very quickly we will be able to work on these professional models deployed by the companies. Okay, and you will be able to generate very effective output. Text summarization, text to text generation, image to image reinforcement learning. In audio classification we can explore some other. Okay, so record from browser, we can record our audio and we can test it on this particular model. So we can check sentiments also, emotion recognition from audio. From somebody's audio we want to see whether this person is happy or not, or neutral or sad. Okay, from dynamic audio recording you can check whether this particular speech or audio is related to a particular sentiment or emotion part. Hubert base for emotion recognition. In speech to text recognition, what we can do for research also we can take. You might have seen that many times we have to refer. So you can see that happy, sad. So highest 71.3% happy from this audio. Any file also you can upload, and from that audio file we can check whether it is related to sad sentiments or happiness or angry or neutral. Many times you might have seen we have to create a content. We want to create a write up about a particular subject, and many times we refer to YouTube videos. So from YouTube videos we can extract audio, And from audio to text or speech to text, we will be able to generate a very good content. Okay, so for content preparation also we can use such AI based models. Extraction of audio from YouTube videos or from any other video, and from that particular audio file we can generate the text. Okay, so any demonstration you can take, any file you can pass and you will be able to work. For example, record from audio. If we are releasing an audio with sad sentiments, it will be able to identify. Click to stop recording, compute. Okay, first of all, we can have its preview also. So you can see in live, we can check, and after that, we can compute sentiment part. Okay, so this was 68.1%. And now, if it is looking fine, then this particular code we can take. So all data sets are already available, already integrated. You can see only in 3 to 4 lines of code in whatever domain we are working. In same way, in computer vision, reinforcement learning, image classification. Okay, so NVIDIA, you can see that very prominent corporate giants are given here. Microsoft algorithm, Facebook, Google. If you want to use Google algorithm, okay, vision transformer. Now we can take any image. Okay, we can upload any image and we can check what is this palace, what is this particular object. Okay, for example, we are taking some particular image from internet. Okay, just for testing it. Okay, anything. For example, we are taking this image, we want to predict what is this using Google algorithm. Okay, so we can upload it, we can check it. So it is giving predictions that lakeside, lakeshore, cinema, movie theater, after that palace, then planetarium, then library. Any other we can take. For example, if we think that it is giving good results, we can import it in our algorithm, in our hardware. So you can see that Jeep, Land Rover, beach wagon, highest accuracy, highest prediction part given to this Jeep. So all of these are quite accurate. Pickup truck. So no need to train anything. All of these, so different orientations, different shapes are available. Okay, we can take creatures also. If you want to see whether it is able to identify creatures also or not, using Google algorithm. So you can see that it is giving predictions. African elephant, tusker, highest accuracy to this part. So if you want to see its source code, so you can see that you on ImageNet, it is already trained in only these scripts, only these lines of code. You will be able to work. In same way, if you want to see any other algorithm by some other company like Microsoft, what about the predictions using Microsoft algorithm? Model is loading, and we'll see what it will predict about this object we have taken. It is also trained on ImageNet. Model description. Okay, AI model description is provided. How to use it? On which data set? Coco data set. So you can see that sports wear, athletic. Okay, in same way, if you want to see this prediction. Now this is apartment, flat, highest accuracy, highest point to this part. And you can see that how many corporate giants, how many users are using it, how many researchers are using it. Last month, more than 6 lakh times this model is downloaded. This is beat model. Okay, if we are using it in our research paper, its citation is also provided. How to cite it in a particular manuscript. Okay, image to text. Every segment it is provided, so you can see that heard of. So it will give a description of images. For example, this complete description of images. A city street with a large building. So we have not given it, we have not labeled it. Using pre-trained model, it has predicted. If you want to see, okay, crowd, just for demonstration, we want to see, okay, if you want to use it in a drone, so that in a particular drone, it should be accurately predicted. Now we want to predict it. What is this? Using pre-trained model of NLP. So you can see that fruit stand with a variety of fruits and vegetables. So we have taken random image from internet. Still, it is able to give very accurate output, very accurate prediction. Another image we can take, for example, this. We are randomly taking some images prediction in AI model like this. Okay, we want to see what it will predict. This model. This is a random image taken from internet, random screenshot, and using this model, AI based model, how much accuracy. So you can see that people walking down a street in a shopping district, how much it is accurate, very, very accurate results. So in drones, in robots, we can use it. Okay, any other image you can take. For example, students class. Any we can take just for testing this AI based model. Its source code is provided. If it is fine, we can put this code in Raspberry Pi, in Arduino board, or wherever we want to deploy. You can see a classroom with a large group of students. Random image, random screenshot is taken from internet, and it is giving very accurate predictions. And this is the source code to be placed in our Raspberry Pi or Arduino board or anything. Okay, hospital. patients. Just for demonstration, if you want to see anything. So in every segment it is available, despite of the domain. So you can see hospital room with a nurse and a patient. We have taken random image, random data, and it is giving very accurate results. So in NLP, in audio classification, in computer vision, everywhere, in every domain, thousands of models available. So multimodal image to text that we have just seen. Visual question answering. You might have seen in visual captcha. It is implemented. Computer vision, video classification, Facebook algorithm. Okay. Or document question answering. Okay. So image generation, image transformation. We can use. To have its analysis to test this particular model. So it is Hugging Face is a repository of so many models. So you can see that we have written only people and it has generated the image, related image, and it is generated dynamically without any plagiarism. It is not taken from internet. It is generating automatically. So you can see that we have written people in the market and dynamically it has generated an image. And using diffusers, so this is the code of diffusers. And more than 30 lakh downloads last month. So obviously so many researchers are using these models, pre-trained frameworks for their research works. So you can see that it's also a dynamic image, text to image, image to text, data sets. If we need data sets related to our work, it can be taken. Okay, open AI wiki text. Because in artificial intelligence, until and unless we will not give good data set, we will not be able to get good results. So to have very effective output, high performance accuracy, data set should be accurate and it should be sufficient. So you can explore it. Sentence transformers are available. Millions of downloads. You can see that more than 3 million downloads. Sentence comparison, some sentence transformations. You might have seen nowadays so many software are used for quilling, for plagiarism removal. So we can work on a particular software. We can create our own software for that part, for effective grammar, for plagiarism processing, using these pre-trained models. There is another platform which provides hundreds of pre-trained models for researchers. That is Model Zoo. In very less lines of code, we are able to work on very effective applications. For example, you are working on some particular data, so spatial data, spatial transformer network. If we want to work on X-ray, MRI, on subjects also, on category wise, we can shortlist the approaches, shortlist these frameworks. Okay, in which domain we want to work: audio and speech, health and biosciences, generative models. So you can see that any of the all of these are completely free and open source, and we can integrate it with our CPU or GPU wherever we want to work in NLP. MRI, brain segmentation. So you can see that this code data results, how much accuracy this model is providing, from where we can take the data set. So you can see it is referring to the Kaggle data set, and with complete documentation, its details is provided, how to use this particular data, how to use this particular model. So on click of get model, we will move to GitHub, and we will be able to work on our own data set for prediction. Deep NLP. So in whatever segment you want to work, so it's up to you whether you want to work on Hugging Face or Model Zoo. As far as comparison is concerned, Hugging Face is having so many models from specifically from corporate giants, from Microsoft, Google, Facebook, WhatsApp. Okay, and preview is also provided. You can see that each and every model is how downloaded millions of times. So you can imagine its prominence. If you want to deploy it on cloud, on Amazon SageMaker, we can deploy on AWS. So you can see that simply which model we want to use, feature extraction, image classification, where we want to deploy on local machine. If we want to deploy it on local machine, its code is provided. We can simply copy and paste, and its examples are also provided. How to run on Hugging Face transformers, running on SageMaker. But is SageMaker? SageMaker is a platform for machine learning and deep learning. Amazon SageMaker. So this is studiolab.sagemaker.aws, completely free. Okay, so you can create account on SageMaker Studio Lab. It is similar to Google Colab. In case of Google Colab, there are limited features. In case of SageMaker, you will get enormous features. You will get a remote system on data center, and we will be able to create very good applications. Computer vision, YOLO V5, YOLO V7, all of these are available on SageMaker.